Hey everybody, today we're in Plymouth, Michigan at Ilmore Engineering, and we're going to go take a sneak peek behind the scenes at what it takes to engineer an engine for the Mastercraft line. So let's meet up with Paul Ray, president of Ilmore Engineering. He's going to give us the VIP tour. Hey Paul.
Hey Zane, how are you?
Good to see you.
Come on in.
All right. So Paul, we're heading into Ilmore's engine assembly shop, and just tell me what goes on here. Like what's that?
Oh, that's a stock car engine. That's the 22 car, ARCA. There's the Penske development team. Same thing over here. We build those here, and these two are getting ready to ship out to a race sometime soon.
Oh, that's awesome. And we've got, even more stuff over here.
That's IndyCar for you. That's probably our biggest business that's done in this shop. We'll build maybe 140, 150 IndyCar engines a year.
Wow.
So it's a pretty busy program for us.
And I know this is the red. This is the Ilmore red. So this is a Mastercraft engine. Now what's it doing here?
This is a development engine. This is an engine that we've been running for a very long period of time. We run durability tests all the time. This engine, 600 hours, just absolutely as complete as you see it in a boat. That way we're testing not just the engine itself, but the brackets and the wiring and the hoses, every single thing that's on there, we're running continuously to see what's going to break, what could possibly fail. And then we tear the engine apart, and every single piece gets thoroughly inspected, the bearings, the pistons, the rings. We're looking for wear, tear, anything that might cause us a problem down the road. We want to know ahead of time so we can put the best product out there.
So Paul, the durability test is really cool, but what I find more fascinating is that the same guys that are working on IndyCar engines and NASCAR engines are working on the Mastercraft engines. So how does that play in for the end user, the new Mastercraft owner?
You want the same people building your products consistently, especially at the development level. So it doesn't really matter whether we're working on motorcycle engines, the pump sections, or the fuel systems, engine teardowns, cylinder heads. It really doesn't matter. You want the most skilled people you can looking at these parts and pieces. When you're pulling an engine apart, you want the same people looking at race engine pieces, looking at the Mastercraft pieces. Same with cylinder heads. You want the same quality built into the development engine process as we build into our race engine process. So it's really important to keep that quality, because what we do here is engineer high performance engines, and that's exactly what we wanted to give to Mastercraft.
Wow, well Paul, this looks like a lab. They don't usually let me in places like this. What's that thing? It looks pricey.
Oh yeah, it is. Yeah, this is probably not something you want to buy for your boat. This is a very sophisticated wiring harness that's straight off an IndyCar. Very, very high-end components, very high-end wiring. Definitely not the sort of thing that you need in a boat. But this is more along the lines. This is the Mastercraft harness. Exact same guys that designed that, though, designed this. We test this in exactly the same way that we would test a product like that. We have a harness tester over there. We have all the test equipment along here that we can test alternators and sensors and so on straight off the boat, straight off an IndyCar. It doesn't matter. Same equipment, same people, same everything.
So Paul, earlier you were telling me it takes about 2 years to go from the raw GM block to the finished Ilmore Marine engine. Why so long?
It takes about a year just to get the engine to a point where we've designed everything, manufactured everything, so we can put it on a dyno and put it in a boat. Once we've done that, it's all about performance, durability, calibration for EPA, CARB, etc. This is a great example. We make all the parts on the engine, but this performance development, we tried different volumes for the 5.7 intake. You see this one's completely different. We liked this one, gave the best performance, so that turned into the 5.7 intake system. This is a great example of fitting it in a boat, some of the problems. Performance development said this was the best plenum we could use. Found out that this is a little too long. It hit the motor box on the 190. And so we had to redesign it. But what we did, got the thing redesigned, got a rapid prototype made by Penske Racing in Mooresville. And we were back on the dyno 36 hours later with a rapid prototype. We were able to test it, no performance loss. So this is what you're going to see on the 6-liter now. But that's that process. That's why it takes 2 years.
Wow. So this is the dyno. This looks like one heck of a commitment. Tell me what goes on in here.
This is really where we do all the load testing for the engines to make sure the engine's durable. This unit back here is the absorption unit. It converts engine power and performance into electrical energy. It's also where we do the durability testing. This is where we run those 600-hour tests I was talking about. We can run the engine 24 hours a day, 7 days a week. Just one guy out there watching it to make sure everything's good.
Very cool. And how does EPA regulations play into this as well?
Well, this dyno is a lot more investment than just an absorption unit. This is actually a full 13 gas emissions certified lab that allows us to do complete EPA dyno certification. We can simulate quite easily the altitude at Colorado, the humidity in Florida, the heat in Egypt. So we by the time we're done in here, we've got fully certified engines that are calibrated for all altitudes and heats and temperatures, etc. But this is only part of the story, of course. Once we feel we've got a good engine, we've got to go to the boat. That's the next stage. You know, we have to put engines in boats and let people drive them to make sure that we've got a really good product across the board.
Well, let's go check out the boat.
All right.
All right, you got an X35, and I remember this X-Star. I think I've been behind it a couple times. Why are you guys doing this type of testing?
Well, this is where we have to put the human element to it. You know, the dyno's like a robot. It'll do the same thing over and over and over again, do exactly what you say. This is where we've got to go testing. We've got to let people drive these boats. We've got to try different engines. We've run in Florida in salt water. We've run in the Great Lakes. We've run in warm water, cold water, brackish water. Anything we can do to actually try out speed control or whatever, it can only happen in a boat. You can't do that on a dyno. So it's very important to get guys like yourself behind these things, driving these things, just to really find out the problems that the human element's going to bring to it.
From their state-of-the-art design capabilities to their seemingly endless hours of testing and validation, Ilmore comes second to none when it comes to R&D.